This is San Jose by night. Electricity means light for our cities. It powers our businesses and it also enables our most common everyday activities. But for millions of people, the difference between night and day can mean the difference between being able to refrigerate your food or having access to a fully powered hospital. And especially in case of disaster where the power structure is affected, this can have really dire consequences. Hi, my name is Anne-Laure Cuvilliez and I'm a graduate student at Stanford University. However, in the case of the Hurricane Sandy, as we can see in this picture, the Goldman Sachs Tower was able to stay powered when the rest of the city was suffering from the outage and was pitch black. So we can see here that there is a certain type of resilient infrastructure that is going to allow people to still have access to electricity even in case of disasters. So what I try to do in my research is to compare the cost and benefits of having a resilient infrastructure, because on one end, the resilient infrastructure can cost more, but at the same time it can save money if it's more resilient and allows businesses to operate in case of disaster. So I know what you're saying.
But this must have been done, right?
But so far there is no method that exists that will allow us to compare the financial benefits of having a more or less disaster resilient electricity infrastructure. So one hypothesis I'm looking at in my research is that decentralization will reduce the amount of outages in case of disasters. In order to look at this, let's dive into the example of Minnesota. One way to look at decentralization of a network is to look at centrality metrics. One of them is betweenness centrality, which looks at how often a node of the network is crossed when you look at all the shortest path between 2 points in the network. On this graph, the most central nodes show up in red and the least central nodes show up in green. So then we take a look at the different service areas of Minnesota, which mean the independently owned utilities, the co-ops, the municipal utilities. And for each service area, we take either the average or the maximum, depending what we want to look at for metrics of the node betweenness centrality. Then, thanks to a GIS software, we can obtain a map that compares the different service areas and how many central nodes they have compared to others. So finally, we can look at correlating this centrality matrix to outage published data in the form of SID, which is an indicator that shows how many minutes of outage is experienced by each customer within a service area. So this overall fits in a more overarching project that will look at renewables and decentralization and how the costs and benefits of those impact regional communities in case of disasters. The final goal is to look at a full system perspective from energy generation to how customers and local businesses are economically impacted in case of disasters. And we hope that by having more informed decision makers, they will be able to arbitrate in favor of a more resilient electricity infrastructure system in the future. Bye, and thank you for watching my video.